Before we get too deep discussing XenApp, we need to make sure that we're on the same page with virtualization. What virtualization is, what virtualization technologies are, and terms and components associated with virtualization. It's extremely important that you understand how the virtualization landscape is built, how it's maintained, how it's managed, and the components that are the makeup of virtualization technology. Throughout the course, I'm going to be mentioning many terms. I'm going to be talking about many different aspects of virtualization from different angles. It's very important that you understand what I'm talking about, not only conceptually, but you understand what I'm talking about practically, from a working perspective. It's crucial that you know how it works, how to set it up, how to configure it, and how to manipulate it with a great deal of ease. First things first, in our building blocks, I need to explain virtualization and what it entails from, at least right now, a conceptual perspective. Let me show you what I'm talking about. So virtualization in all technologies, really you start with hardware, base hardware. Now this hardware can be a laptop, it can be a desktop, it can be server quality hardware, it can be anything really. So you take this hardware, and on this hardware you have a host operating system, and then you have what is called a hypervisor. Hypervisor comes in a couple of flavors. I'm going to talk to you about that in just a minute. But hypervisor is generally responsible for virtualizing this physical hardware. So, if this piece of hardware has 16 gigs of RAM, let's say, hypervisor is responsible for allowing the 16 gigs of RAM to be virtualized so that it can be distributed among virtual machines on that hardware. So let's say, for the sake of argument or for the sake of our discussion, that this hardware is a Dell PowerEdge 1950 server, which is what I'm going to be using coincidentally for my labs. So let's say that's the case right here. Let's say that this is a Dell PowerEdge 1950 server. And this server right here, of course, corresponds, this name, for example, corresponds to a certain type of server hardware with X amount of RAM, X amount of disk space, and X amount of resources in general. When we are talking about hardware resources, we are really talking about quite a few things, but very specific things. Hardware resources really involves, if I really were to talk about resources associated with hardware, I'm talking about network, I'm talking about storage, I'm talking about RAM, and I'm talking about processor. Okay? These are the four components that make up resources on any machine that, or any piece of hardware you're ever discussing. Anytime someone is talking about system resources, they're talking about one or more out of these four. So, this server hardware right over here, whatever amount of resources it has on it, these resources by the power or the magic of the hypervisor are allowed to be shared among the virtual machines right over here. This hardware, in my example here, is a Dell PowerEdge 1950 server. We can call this thing the host hardware or the host server. On this host hardware or the host server, there is a host operating system that is housing our hypervisor. Hypervisor is going to allow multiple virtual machines to be constructed on the host hardware. Each virtual machine will have its own guest operating system. So, for example, in this particular instance, maybe one guest operating system is a Windows OS. Okay. One guest operating system, let's say, is a Linux-based OS. And maybe another one is maybe Solaris or some flavor of Unix. just as an example. Okay? So each one of these operating systems can be something different. The benefit, one of the great benefits, there are many, 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 one of the great benefits is that this guest operating system does not have to be aware of the physical hardware that is underneath the hood, if you will. The guest operating system is unaware about the amount of resources, the total amount of resources that are available on this host hardware. I may have 16 gigs of RAM, as an example. It's not really a lot. I may have, let's say, 16 gigs of RAM on the host hardware. I may have quad core processors. Okay. I may have quad core processors. And I may have dual network cards, dual physical network cards. And I may have, terabytes of disk space available in this particular instance. This virtual machine right over here, or these virtual machines right over here, don't have to be aware of the physical resources I have available on this host operating system that the host operating system has access to, or the host hardware has access to. The only thing these guest operating systems know about is really whatever the hypervisor has presented them with. So, for example, for this Windows operating system, maybe, not that it would be a good idea, but maybe we allocate 4 gigs of RAM. Okay? And maybe for the Linux operating system, I allocate 1 gig of RAM. And maybe for the Unix operating system, I allocate 3 gigs of RAM. Let's say. Okay? Now, what ends up happening is that in this instance, in the instance or the example that I'm giving you here, I've got 4 gig plus 1 gig is 5 gig plus 3 gig is 8 gig. This 8 gig is going to have X amount of overhead associated with it, whatever that is. Let's say that there's a couple hundred megs of overhead that is used up by the hypervisor. The hypervisor will take the amount of resources allocated to these VMs and add its own overhead so that it can manage what's happening here. So, the 16 gigs of RAM in this particular instance that I've got total, I'm using up 8 gigs of it, and among the 8 gig, I've got 3 virtual machines loaded inside of this host OS, as an example. Okay? This virtual hardware right here, the virtual hardware that has been presented by the hypervisor, this virtual hardware does not only refer to the amount of RAM, it really refers to all of these resources, network, storage, RAM, and processor, and it also refers to a few things that are not mentioned here. For example, keyboard, mouse, and video. All of these virtual machines are accessible and provide access to virtual keyboard, virtual mouse, and virtual monitor, or virtual video, if you will. Depending on the kind of hypervisor it is, and depending on the kind of virtual machines they are, maybe these virtual machines are designed or created for the purposes of server hardware or server equipment. Maybe these virtual machines are created and optimized for desktops. Depends. Depends on what kind of hypervisor it is, and depends on what the virtual machines were designated to do. It's not necessary that the Windows operating system is going to be used for server hardware or the Linux OS or the Unix OS. And it's not necessary that they would be used for server OS either. So we have a host operating system. We have a hypervisor. We have our host hardware. In this particular instance, I'm talking about Dell hardware, for example. I've got a few resources here in terms of RAM, processor, disk, and memory. These are the 4 major resources. Of course, there are many others, and I mentioned to you keyboard, mouse, and monitor are some of them. You got multiple virtual machines that are known as guest operating systems. Okay? And then on these guest operating systems, you install applications. Now, these applications can be really anything. These applications can be, for example, maybe this is going to be a database server. Okay? Maybe on the other VMs, maybe this is going to be a VPN tunnel gateway, maybe this will be a DNS server, really, who knows? Could be any number of things. So you can install on these guest operating systems, you can treat the guest operating system as if it was a physical machine. The virtual hardware that has been presented to the guest operating system is completely usable. The Windows operating system does not know, nor does it care, that it has been presented with virtual hardware. It, the Windows OS, or the Linux OS, or the Unix OS, believes that the amount of resources presented to them are physical in nature, and they can't tell the difference. So this hypervisor abstracts away the physical resources associated with the host hardware. In other words, if I want to move this guest machine from one host hypervisor or one host hardware to another, I could do so very easily. And here's what I'm talking about. I could, for example, I can take, and you're going to find this kind of interesting, and in the physical world, this would be, well, very difficult to say the least. But in the virtual universe, it's rather simple. I could take, for example, let's say I'm going to take this entire virtualization structure, and I'm going to make another one out of it, like so. So I've got, and this is representing two hypervisors, two host operating systems, and multiple virtual machines. What I can do in this particular instance is, if I remove this, I can actually take these virtual machines right over here, and I can just simply move them over here if I want to. Okay? I can leave them exactly where they are. Okay? So the movement of the VMs is also very much facilitated by the virtual hardware. So let me explain here. If I'm going to open up another scenario here, I'm going to show you an example that I think, at least from a conceptual perspective, that will make a little bit more sense. So I can do this. I can take this and I can make a copy of it right over here. And let's say that this particular hardware right over here was a Dell PowerEdge 1950 box with 16 gigs of RAM and dual quad-core processors. Okay? And I had 1 terabyte of disk space on it. And so I've got this hardware, and over here, I have a HP hardware. Okay, I've got HP hardware with a quad-core 64-bit processor with 512 gigs of RAM, and I have 16 terabytes of fiber channel SAN access on it. Okay? So this means that this particular piece of hardware, in this particular instance, this piece of hardware has more resources than this one. And maybe I am letting go of this particular Dell server, maybe because it's too old. In my instance, what I'm using for my labs is kind of old. So I can take all of the virtual machines that are located over here, and I can simply migrate them right here. Okay? Very, very easily. So that, and I don't have to worry about bringing the virtual machines down because I can do the migration while the VMs are running. I can also, let me take this, I can shrink this in this particular instance, and I can choose to do something like this to give you an example, and I can shrink this, and I can move these right over here. Yeah, this is exactly how it happens too. I know it seems kind of funny because I'm moving it in the what seems like in my little drawing, but that's how it really happens in the physical universe as well. I'm able to add machines and manipulate machines out of my environment. Once I've moved all the machines over, I can simply take this particular piece of hardware and decommission it like so. And yes, it is kind of that simple. You simply move the virtual machines over and you can decommission the hardware. Not only can you decommission the hardware, you can maybe expand it. You can upgrade it. You can, if you want, you can add more RAM, add more processor, and really do whatever you want to do with it. And you're able to make, you can, if this particular new piece of hardware has got sufficient equipment in resources, and I'm talking about RAM, processor, disk, and network, you're simply able to add more VMs to it as you please. Okay. So, to take this further, to take this to the next step, as I was talking to you about hypervisor, and I mentioned to you that there are a couple of different kinds of hypervisors. Here's what I was talking about. So what happens is that there are two different kinds of hypervisors. There are two approaches to hypervisors, if you will. Okay? There is a type 2 hypervisor, and there's a type 1 hypervisor. Okay? So a type 2 hypervisor, right here, you have a hardware, and then you have a host operating system, and then you have a hypervisor on top of it. Type 1 hypervisor, you have hardware, and then you have a hypervisor right on top of it. What is the difference? Well, I'm glad you asked. In this particular instance, right here, this type 1 hypervisor, this means that the operating system is installed on bare metal. Okay. It says that the type 1 or bare metal hypervisor is really the one that is used in the production environment that we're going to be using as well. So here's the thing. You have hardware in this particular instance, and let's say that in my case, and it is, in my case, I've got a Dell PowerEdge 1950 box. And on the Dell PowerEdge 1950 box, I'm going to install XenServer on it. Citrix XenServer on it. Citrix XenServer is an example of a type 1 hypervisor. The reason is that it is an example of a type 1 hypervisor is because it installs directly on the hardware. Okay? That's why it is a type 1 hypervisor. These operating systems right here that it's talking about, right over here, these are guest operating systems, right there. This is a guest, and so is this. Okay? These are guest operating systems. Namely, these guest operating systems can be Windows, the guest operating systems can be Linux or Unix. And then on these guest operating systems is where you have your applications that are installed on it. So we are using a type 1 hypervisor, namely, we are using Citrix XenServer. Another example of a type 1 hypervisor is VMware. And another example of a type 1 hypervisor is Microsoft's Hyper-V product. Okay? So all of them install on bare metal. They don't need another operating system other than the one that is inside of the bare metal, in this particular instance, the hypervisor itself. Citrix XenServer and VMware ESX are both built on the Linux OS. Microsoft Hyper-V is built on the Windows OS. Okay? So that's a type 1 hypervisor. Okay? So what is a type 2 hypervisor? Well, a type 2 hypervisor, as you might imagine, is not installed on bare metal. Type 2 hypervisor relies on a host-based operating system in order to be able to work. So what is the drawback of a type 2 operating system? Well, the thing is that in the case of a type 2 operating system or the type 2 hypervisor, is that the type 2 hypervisor will have limitations set forth by the operating system that it is installed on. Okay? So in this particular instance, a type 2 hypervisor, an example of a type 2 hypervisor is Oracle's VirtualBox technology. And I'll show you the example of that. Oracle has a product called VirtualBox. VMware has a product called VMware Player or VMware Workstation. Both of these are, all three of these rather, are type 2 hypervisors. They don't have an operating system of their own. They are installed on top of an operating system that exists, whether it be Linux or Windows. To give you an example, here is Oracle VirtualBox. This is a type 2 hypervisor. On this type 2 hypervisor, or this Oracle VirtualBox, it is installed on top of my Windows environment. As you can see, here's my Windows environment, and Oracle VirtualBox is installed on top of it. If I was to go into my device manager, I would be able to see Oracle's VirtualBox environment sitting there, allowing me to manage it and manipulate it. Now look right here. Here is the Oracle VirtualBox's host-only network that it installed as part of installing the Oracle VirtualBox software. It installed its own driver for its own network. This is the physical network card that I have installed on this machine. Oracle VirtualBox installed its own driver for the purposes of virtualization. And on this, I've got a couple of different operating systems installed. Well, I've got a couple of different virtual machines installed. So here's CentOS. I can just power this machine on. It's based on a 32-bit operating system. It's powering on this Red Hat system. And here is the machine being powered on, the virtual machine being powered on. And this virtual machine sits inside of this Windows-based OS. The type 2 hypervisor has limitations that are based on the limitations of the host OS. It would not be able to do anything that the host OS doesn't let it do. Its movements, expandability, distribution components, enterprise-ready components, network capabilities, all of them are dictated by the host, in this case, the Windows-based OS. So a type 2 hypervisor relies on the operating system and its limitation in order to be able to dictate what the virtual machines can and can't do. Okay? A type 1 hypervisor does not require a separate host operating system. It has its own set of structures. Type 1 hypervisors are the ones that are used in production and for the purposes of enterprise readiness, if you will. Type 1 hypervisors are the ones that are used in order to be able to support, promote, create a virtual environment, a cloud, and certainly enterprise-ready applications such as XenApp should be installed on a Type 1 hypervisor. Not to say that they cannot be installed on Type 2 hypervisor, but for the purposes of production readiness or production purposes and enterprise readiness, you want to install it on a Type 1 hypervisor. I will be using Citrix XenServer, for example. You can use VMware ESXi. You can certainly use Microsoft Hyper-V as well. So that's the difference between a Type 2 and a Type 1 hypervisor. Here you can see on a Type 2 hypervisor, I've got a virtual machine that is already installed that I'm logging onto, and here it is working, and it understands, here it is, entire CentOS operating system that is created and installed on top of this Type 2 or Oracle VirtualBox hypervisor. Okay? So hopefully you have a little bit of an understanding associated with virtual machines and hypervisors and what they are. And there's a lot more to come, a lot more to follow. Please stay tuned. I'm very glad you're here.
Start with new learning now.